You know, when you sit down in front of a computer screen and load up a really hyper-realistic video game, you can just get completely lost in it. You see towering mountains, you see shifting clouds, sunlight reflecting off the water.
Right, yeah, your brain just processes all of it as a world.
Exactly. But, you know, with absolute certainty that underneath that visual, there are no mountains.
There's no water.
Right. There's no water. It's just code. It is an unimaginably intricate arrangement of ones and zeros just shifting on a processor.
Yeah, it's a compelling illusion of solid reality, but it's built from the ground up entirely on binary logic. So it feels real to the observer, but the foundation is purely mathematical.
Which naturally makes you wonder, you know, if you walk outside and leave the screen behind and zoom in far enough on an actual mountain or a real sky, do you just find more code? Like, is the real world just a higher resolution simulation running on a bigger machine? Welcome to today's deep dive. We are taking a massive swing at that exact question today, really looking at the fundamental nature of reality, information, and, well, consciousness itself.
And we've got some incredible sources to unpack this.
Yeah, we're exploring this sort of wild theoretical battle. On one side, we have theories like digital physics arguing the universe is just data. We have a comprehensive breakdown of that, along with a razor-sharp critique of it by Raymond Tallis from Philosophy Now. And on the other side, we're looking at a paradigm-shifting scientific paper on integrated information theory, or IIT, by Giulio, Tononi, and Melanie Boly.
Right, and their work flips the script entirely.
Right.
Suggesting that instead of everything being cold data, consciousness might just be the most fundamental, real thing in existence.
Okay, let's unpack this. Starting with that first idea, digital physics. The theory that the universe is quite literally a computer. I always just thought of this as a sort of modern Matrix-era sci-fi trope.
Making videos isn't easy. If you have the means and the interest, please consider supporting us by checking out the products from the Zero Dimension shop at the bottom left of the video.
Conrad Zuse published a book called Calculating Space. He was the first to formally suggest the universe is being computed by this vast network of deterministic or probabilistic programs.
Wow, 1969.
Yeah, and then jumping to 1978, the physicist Edward Fredkin coined the actual term digital physics. He was so committed to this idea that the fundamental fabric of reality was informational that he ended up teaching a course on it at MIT.
So the idea is that instead of the fundamental Lego blocks of reality being physical things like quarks or atoms, the absolute bottom layer of existence is a bit of information, a 1 or a 0.
Exactly, on or off. The legendary physicist Richard Feynman even entertained this conceptually. He compared a single point in the vacuum of space-time to a computer with an input and an output.
Okay, wait, a point in space is a computer?
Yeah, he imagined that a microscopic point in space has a memory for all the possible fields and particles that could pass through it, acting exactly like a computational device processing data.
Which sounds completely absurd to our everyday common sense until you actually look at how quantum mechanics operates. Because when you get down to the smallest levels of reality, things get weirdly mathematical.
Profoundly strange, yeah.
Yeah.
When we bring quantum mechanics into the fold, we run into Heisenberg's uncertainty principle and Niels Bohr's famous conclusion that unobserved electrons don't actually exist anywhere specific until they are measured.
Right, they're not tiny physical spheres.
No, before measurement, they're just clouds of probability.
So they're essentially waiting for the system to ask them a question. Are you here or are you there?
And that specific mechanism is what led the great physicist John Wheeler to coin his famous phrase.
Oh, right. It from bit.
Exactly. It from bit.
Meaning every physical it, every particle, every table, every star derives its ultimate significance from bits, which are just binary yes or no answers to interrogations of nature.
Yeah, Wheeler argued that no phenomenon is a real phenomenon until it is an observed phenomenon. In this framework, the fundamental stuff of the world simply isn't matter. Matter is a secondary byproduct. The primary currency of the universe is information.
But here's where it gets really interesting. If the universe is running on code, where is the hard drive? What are those ones and zeros actually written on? Because ones and zeros are just relational concepts. A 0 only means off relative to whatever on is. It's just a marker of difference. Don't you need physical stuff like hardware to even have software?
And that leap from the theoretical to the physical is exactly the flaw philosophers point out. In that Philosophy Now article, Raymond Tallis attacks this head on. He has a brilliant term for it. He calls bits ontological parasites.
Ontological parasites, meaning they feed off the existence of something else.
Precisely. Bits only exist because they borrow meaning from one another, and ultimately, they borrow their meaning from a conscious observer. Information isn't just a physical substance floating around in the void. For information to actually be information, it requires a subject who is conscious of it to interpret it.
Tallis uses this fascinating example of a coin toss to prove this, and I really want to dig into it. Because when I flip a quarter, we universally agree that the result is one bit of information. It lands, it's either heads or tails, 1 or 0. It seems like the purest example of the universe generating a binary bit of data.
But let's look closer at what happens physically during that coin toss. Forget the game you're playing and just look at the physics of the object moving through space. What is actually happening?
Well, the coin is spinning. It's moving through the air, hitting air molecules.
And how many air molecules? What is the exact rotational velocity? When it lands in the dirt, what is the precise angle of the impact? How many blades of grass does it bend? How many microscopic grains of soil cling to the ridges on the edge of the coin?
Oh, right. There are millions, probably billions of physical outcomes and interactions happening in that single second.
If you describe the outcome of that coin toss in purely physical terms, drilling down to the atomic level, a single flip yields trillions of bits of data. It only delivers exactly one bit of information, heads or tails, because a conscious human being completely ignores all those other physical realities.
Wow.
We decide, based purely on arbitrary human convention, that only those two flat sides of the metal disc matter.
So the universe doesn't care if it's heads or tails. The universe just does the staggering physics of spinning metal colliding with the ground. The information of heads or tails only exists because we are there to extract it. And we only extract it because we are selectively ignoring the rest of reality.
Exactly. Without conscious subjects, there's no intrinsic quantification in the universe. Tallis argues that a universe composed purely of bits would lack the conscious subjects required to sustain it and give those bits meaning. A simulated, purely informational world will always require a non-simulated simulator to observe it.
That makes total sense from a philosophical standpoint. But the physicists themselves have started poking holes in digital physics too, haven't they?
They have, yeah. Existing models of digital physics struggle massively to explain continuous symmetries in physical laws. Things like rotational symmetry or translational symmetry, which are central to how we understand physics today.
Can you break that down? What does rotational symmetry mean for a digital universe?
Sure. So imagine looking at a perfectly smooth circle printed on a piece of paper. If you rotate that paper, the circle still looks perfectly smooth. That is continuous symmetry. The laws of physics allow for perfectly smooth movement in any direction.
Right.
But if the universe is fundamentally a digital grid, like a checkerboard made of discrete bits of information, moving things smoothly or rotating them perfectly becomes mathematically impossible at the smallest scales.
It's like trying to rotate a pixelated image in a retro video game. Yeah. The pixels are fixed squares. If you try to turn a diagonal line, the edges suddenly get jagged and blocky. The smooth reality breaks down because the grid can't handle the angles.
That is a perfect way to visualize it. Nature doesn't show those jagged pixels when we look closely. And furthermore, there is an even bigger roadblock involving quantum entanglement. Digital physics models belong to a class of theories that rely on local hidden variables. Basically, the idea that for a bit on the grid to change, it has to communicate with the bit directly next to it.
Like a domino falling into the next domino, a local step-by-step process.
Yes. But Bell's theorem, which has been experimentally proven, showed that particles can instantly affect each other across vast distances. This is quantum entanglement, or what Einstein called skooky action at a distance.
Right.
You cannot have instantaneous long-distance communication in a basic step-by-step digital grid without completely breaking the code. So, treating the universe as a giant digital computer faces massive hurdles on both philosophical and physical fronts.
Which brings us to an incredible pivot. Because if Tallis is right, and information only means something when a conscious subject is there to interpret it, well, maybe science has had its starting point completely backward this entire time. For centuries, we've started with physical matter, like atoms, molecules, brain cells, and tried to figure out how to squeeze consciousness out of it.
Right. This is known in philosophy and neuroscience as the hard problem of consciousness. How does dead matter suddenly wake up, look around, and feel things? It remains one of the greatest mysteries in human knowledge.
But what if we don't start with the dead matter? What if we start with the consciousness?
This is where we dive into integrated information theory, or IIT, developed by Giulio, Tononi, and Melanie Boly. IIT represents a radical paradigm shift. Standard science takes what we call the extrinsic perspective. It observes objects from the outside. You look at a brain in an MRI machine. IIT takes the intrinsic perspective. It says, wait a minute. The only thing we immediately and irrefutably know exists is our own conscious experience.
Yeah.
Before you know you have a brain, before you know the universe exists, you know that you are experiencing something.
Yeah.
Therefore, consciousness itself is the foundational reality.
Yeah.
They call it intrinsic existence.
If I'm understanding this, it is kind of like looking at a painting. Standard science studies the canvas, the chemical makeup of the paint, the exact weight of the brush strokes, and then tries to explain why we feel sad looking at it. IIT says, no, the feeling of sadness is the absolute bedrock fact of existence.
Exactly.
The feeling is real. Now let's work backward and figure out what physical structure in the brain maps exactly to that feeling.
Yes, instead of asking how matter creates magic, IIT asks, what physical properties are required to support the reality of experience? IIP defines physical existence operationally as cause-effect power, the ability to take a difference and make
Making videos isn't easy. If you have the means and the interest, please consider supporting us by checking out the products from the zero-dimension shop at the bottom left of the video.
And IIT says these 5 axioms must map perfectly onto physical cause-effect structures in your brain.
I want to really grasp this rather than just running through a list of terms. Let's do a thought experiment. Say I am looking at a bright red apple on my kitchen table. How do these 5 axioms explain that experience?
Let's walk through it. The first axiom is intrinsicality. When you experience that red apple, the experience exists for itself, from its own intrinsic perspective. It doesn't need an outside observer to validate it. It is happening to you subjectively. Physically, this means the neural circuitry in your brain must have cause-effect power upon itself.
So it isn't just passing signals to a screen, it is affecting its own state. Okay, the experience is mine. What's the second?
Information. This means the experience is specific. You are seeing a red apple. You are not seeing a blue car or smelling a rose or hearing a siren.
So it's defined by what it is, but also by all the millions of things that it isn't.
Exactly. In the brain, this means the physical system must select a highly specific cause and effect state, differing from a massive repertoire of other possible states it could have taken.
Okay.
The third axiom is integration. When you look at that apple on the table, you don't see the redness entirely separate from the roundness. You can't experience the left side of your vision independently from the right side. The scene is unitary.
Right. I can't split my consciousness in half. It's one irreducible whole.
Physically, this means the cause-effect power in the brain must also be unitary. The network of neurons generating this cannot be cut into separate, independent parts without destroying the specific experience.
That makes sense.
The fourth axiom is exclusion. The experience of the apple is definite. It includes exactly what it includes. No more, no less. It has a boundary.
Meaning I don't simultaneously experience the apple and the feeling of my blood pumping through my veins, or the subconscious processes regulating my breathing. My conscious experience draws a line.
Which implies that the physical complex in the brain must also be definite, maximizing this irreducible cause-effect power over a specific set of neurons and actively excluding others. And finally, composition. The experience is structured. You don't just see a red blur. You see an apple sitting on a table, perhaps with a shadow casting to the right.
There are elements, and they relate to each other.
In IIT, subgroups of neurons specify overlapping causes and effects, yielding a massive, intricate cause-effect structure. The theory posits an explanatory identity, meaning the geometric properties of this physical cause-effect structure fully 100% account for all the subjective properties of the experience.
Wait, I need to push back here, because this is where IIT gets incredibly dense, this concept that quality is structure. Tononi argues that the feeling of space, like looking down a deep 3D canyon or feeling the flow of time, is just the physical geometry of neurons firing.
Yeah.
That sounds like a magic trick to me. How does a 2D grid of meat in my head literally become the feeling of spatial depth?
It is not magic. It's actually pure geometry and causality. Let's break it down. If your neurons were wired in a single straight line, your experience of the world would be essentially one-dimensional.
Okay.
But inside the brain's main complex, primarily the posterior central cortex, the neurons are wired in dense, overlapping, highly interconnected grids. When they fire, they constrain the probability of what the other neurons around them will do next.
So they're constantly echoing off of each other.
Think of it like a three-dimensional web of tension. Because of how they are physically linked, the cause and effect power bounces around in a complex geometric shape. When you look at that canyon, you aren't just processing a flat photograph. The physical architecture of those overlapping neural connections creates a web of relations, distance, inclusion, connection.
Oh, wow.
You don't see space as a picture. You are experiencing the literal shape of the electrical echoes in your brain. That geometry of cause and effect is the feeling of spatial extendedness.
So we don't process reality like a camera taking a 30-millisecond snapshot. Because the cause and effect power overlaps, we experience reality as a continuous flowing structure.
Yes.
The meaning isn't something decoded later by a little man sitting in another part of the brain. The meaning is the feeling. The structure is the experience.
That is the genius of IIT. The feeling of the color blue or the shape of a face or the flow of a melody, they are structural cause-effect geometries occurring here and now. The meaning is entirely generated from within by that physical structure holding itself together.
So if consciousness requires this specific, overlapping, integrated physical structure, what does that mean for artificial intelligence? Because we are seeing supercomputers today that can pass the Turing test, perfectly mimic human conversation, write beautiful poetry. Based on IIT, is an advanced AI conscious? Does it feel anything?
IIT provides a very definitive and perhaps unsettling answer to this.
No.
Based on those 5 axioms, a standard von Neumann computer, which is the architecture all our current AI runs on, could be functionally equivalent to us. It could replicate our behavior flawlessly, but it would never be phenomenally equivalent.
Why not? If it's processing the exact same information and outputting the same poem, why doesn't it feel the same?
It comes down to the hardware architecture.
Yeah.
Think about how a computer logic gate processes data. It uses feed-forward processing. The signals move in one direction down the line. To use an analogy, think of feed-forward processing like a bucket brigade putting out a fire. Each person passes the bucket to the next person in line. They do their job perfectly, but they have no idea what the rest of the line is doing. They are completely isolated.
They just take the input and pass the output.
Yes. The human brain, however, is recurrent. It is more like a massive choir, where every singer is constantly listening to and adjusting to the voices of everyone else simultaneously. Because standard AI is just a linear bucket brigade, when you analyze it for integrated cause-effect power, the system mathematically disintegrates into millions of tiny isolated modules. It doesn't have that unified whole system awareness.
It lacks that dense, overlapping, echoing grid that our brain has. So according to IIT, a highly intelligent AI is doing without being. It might write a heartbreaking poem about a sunset, but internally it experiences absolute darkness. It is a zombie.
It feels like nothing at all. Which brings us to a profound concept in Tononi paper called the Great Divide of Being.
The Great Divide of Being. What does that separate?
It separates the entire universe into 2 stark categories. On one side, you have intrinsic entities. These are conscious beings that exist for themselves. Because of their highly integrated brain structures, they possess genuine cause-effect power over themselves. There is something that it is like to be them.
And on the other side of the divide?
Extrinsic entities. Things that only exist relative to an observer, a rock, a feed-forward computer. If you are listening to this deep dive on your commute right now, think about this. The car you were sitting in, the asphalt on the road, even your own hands resting on the steering wheel, those are extrinsic entities.
Wait, my own hands are extrinsic?
According to IIT, yes. Your body as a whole functions together, but doesn't have a single unified cause-effect power across the entire structure. Your hand doesn't feel itself. It is essentially an aggregate of what they call ontological dust. The only part of you that genuinely, intrinsically exists in the universe is the conscious experience generated by that main complex in your brain. Everything else is just physical stuff doing things.
That is wild. If you're on a commute right now, IoT is basically saying that the only thing that truly fundamentally exists in that moment is the feeling of you experiencing the drive.
Yeah.
That completely flips how we view our place in the universe. Think about how science has historically treated humanity. We've been constantly displaced and humbled. Galileo proved the Earth isn't the center of the solar system. We're just a speck in the cosmos.
Right.
Darwin showed us we aren't a special creation. We're a product of blind evolutionary chance.
And Francis Crick, the co-discoverer of DNA, famously claimed that your joys, your sorrows, your ambitions, and your free will are nothing more than the behavior of a vast assembly of nerve cells. We were reduced to just chemistry.
And now AI threatens to prove that even our intelligence is just a mechanical process that can be replicated by silicon. It's a very bleak, meaningless view of humanity. We're just passengers on a ride we don't control.
But IIT reverses every single one of those historical displacements. If consciousness is the most fundamental bedrock reality, then we aren't just a byproduct of atoms. IIT argues a principle that only what exists can cause, meaning your intrinsic decisions, your reasons, your values, because they exist as real,
Making videos isn't easy. If you have the means and the interest, please consider supporting us by checking out the products from the zero dimension shot at the bottom left of the video.
We are the ones steering.
Yes. Your inner life, rather than being an illusion or a useless byproduct, is arguably the most real, massive, and complex structure in the known universe. You are not a tiny speck. You are a staggering geometry of meaning.
I love that phrase, a staggering geometry of meaning. Which brings me to one final, completely mind-bending thought to leave our listeners with today. We talked about how an AI supercomputer could have massive intelligence, but absolutely zero consciousness. What about the reverse?
You're asking if intelligence and consciousness can be entirely decoupled in the other direction.
Right. Think about brain organoids. Scientists are currently engineering clumps of human brain cells in petri dishes. Say they manage to grow an organoid that perfectly reproduces the posterior central cortex of a human brain, that incredibly dense, overlapping, grid-like structure we talked about.
From an extrinsic perspective, it would look completely useless. It would have no eyes to see, no ears to hear, no muscles to move. It would have zero intelligence. It couldn't perform a single behavior or solve a single problem.
But internally, based on the axioms of IIT, because of its integrated physical structure, it could be vividly conscious.
Yes.
It could be floating in a dark lab, dreaming of brilliant colors or spatial extendedness in total isolation, which means a blind, deaf, completely useless clump of lab-grown cells could be infinitely more conscious and infinitely more real than the most advanced AI supercomputer on Earth.
It forces us to entirely rethink what it means to exist and what we value. Are we building a future that only values the things that do? Or will we protect and value the things that can truly be?
That is the ultimate question. So the next time you look at a breathtaking view or feel the warmth of the sun on your skin, remember, you aren't just a passive observer watching a simulation of ones and zeros. That feeling is the fundamental structure of reality itself happening inside you. You are the hardware, the software, and the meaning all at once. Until next time, keep diving deep.